little intricate commands that are not published that you have to do. So, all right, the first thing is open up Packet Tracer. Open up your lab. And just kind of put these things in here. Now, if you want to put the servers in, you're more than welcome to. I'm not looking for that. I'm going to be grading the configs of the R1, the firewall only. So I'm not really doing much on the switches. Not that you shouldn't harden them anyway, but the config of the router and the firewall are paramount. So 2 routers, firewall, a couple switches. Pretty easy. So if you want to follow along, if you want to work ahead, by all means. All right, the routers I'm going to use for this are the 2911. Be my ISP. All right, so it's going to be ISP is the display name. Host name is ISP. All right, and another 2911 for R1. I'll grab a couple of 2960 switches. Alright, so R1. And SW1, and this will be, I guess, an SW2. Okay, and down here, it's kind of hard to see, but you're looking for the thing with the bricks at the bottom. That's your firewall. Oops. Okay, you only have one choice at 5505. All right, and it's hard to see on this graphic, but the host name is FW1. FW1. Alright, everybody with me? Okay, and it's got to connect everything up again for the diagram. So, yeah, it's kind of hard to see. Let me zoom in here a little bit. So they have fast Ethernet 01 on the ISP to fast Ethernet 00 to R1, fast Ethernet 00 to gig 0, gig 1, it goes the inside to your switch 2, gig 2 to your switch 1. It's all Ethernet. Between the router, you'll have to do a crossover cable. And actually here I'm doing gigabit Ethernet, so everything's going to be gigabit Ethernet. Okay, and you have to do crossover from R1 to the firewall, which is going to be Ethernet 0. Alright, a straight through on 0, 1 to pretty much any port on the switch, and a straight through cable on gig 02 to any port on switch number 1. Okay? That's kind of what it looks like. Now if you want to drag and drop endpoints, servers or whatever, over here, you're more than welcome to do so. Connect them up. I'm not going to do that right now. Do that at a later date and time, or like I said, if you want to do it for testing purposes, that's dandy. Okay? reason these aren't up yet is because I haven't configured them. Haven't turned the interfaces on. So, that said, number 2, put all your IP addresses in. All right. So, starting with ISP1. Go to the command line. I'm already in global configuration mode. That's very nice. I'm going to go to interface gig01. And give it an IP address of 204.184.21.33. Is a 30-bit 7-bit mask. Turn it on. That's all you really have to do for the ISP. You can put additional routes in the ISP if you want to. I'll get to that later. When you get to routing. But for now, that will suffice. On R1, G00 faces the ISP, and its IP address is 204.184.21.34. Again, a 30-bit 7-bit mask. Turn it on. Change things up, and you should now that linked up in green. So we'll do the same thing for R1 to the firewall. Alright, so its IP address is 204.184.21.29 again /30. So I'm just going to go to int G0/1. We add 204.184.21.29 30-bit. Turn it on. Okay? Now, when we get to the switches here, we'll do switch 1. It needs IP of .29. Switch 1. So we just need to make an interface VLAN. It's all in VLAN 1. Int VLAN 1. IP add 192.168.0.29. And it's got a 26-bit 7-bit mask, which is .224. You don't have to turn it on. It's automatically connected. It'll pop up. It should pop up. But if you're more comfortable, you can do no show. Go. Actually, I guess I push it now. Okay. All right. This is just a flat switch. It does not have an IP address. If you want to give it an IP address, you can. All right. So let's get into the firewall here. So with the ASA, the command syntax is a little bit different. There's no username, password. You just hit enter. That's how I got to privileged exec mode. All right. So it kind of sort of has some iOS commands, but there's a couple things different about it. All right. First off, if you do just a show run to look at the configuration, you will see all the interfaces and the VLANs. Right now there are 2 VLANs. They both have a name inside and outside, which is perfectly fine. The outside is set up for DHCP, so it thinks it's going to get a DHCP address from somewhere. All right, so we need to disable that. We also need to take the DHCP configuration out of this firewall, including its network, to kind of clean it up a little bit. Like I said, there's some things that we kind of need to do. Also, VLAN 1, we need to get rid of that IP address, as we're not dealing with a 192.168.1, you're dealing with 10.0.0. So, I'm going to do that first. You go into global configuration mode, just like a router, config T. All right? And you go into interfaces, just like a router. So I'm going to go into interface VLAN 2. And I'm going to do no IP add DHCP. Okay? The do command doesn't work. It's automatically inherited. So if you just want to do a show run from anywhere, you can. All right? I need to take the DHCP settings out. Right there. So I'm going to exit out to global configuration mode because I'm in an interface. I'm going to type no DHCP auto config outside. And then I'm going to do no DHCP D address or add 192.168.1.5 dash 192.168.1.36 inside. You need to type the whole thing out. Just put a no in front of it. Okay? And then I'm going to take the DHCP server offline with the no DHCPD enable inside. We're going to put it back in. Just not right now. Okay. Now that I've cleared all that, I can take the IP address off of the inside interface. So I'm going to do show run, which is VLAN 1. I'm going to go back into VLAN 1, int VLAN 1, no IP add. Okay, you'll get the DHCP, hey, you cleared all this stuff out, that's fine. All right? So if I can control Z out and I do a show run, I have a pretty much clean thing. But my host name still says Cisco ASA. What should it say for the lab?
Say
It's right there in black and white on the diagram. It's kind of hard to see. It's in the bricks. It's FW1. All right? So let's go ahead and get that fixed. Config T, just like on a router, host name, and then whatever the host name is going to be. So host name FW1. Promptly change. Okay. Now we can start configuring IP addresses on all these interfaces. So we have 204.184.21.20. On gig 0, which is our outside interface. This is where it gets a little confusing because you do not put the IP addresses on the interface themselves. There's basically an 8-port switch on a 5505, all right? And a lot of smaller firewalls, regardless of manufacturer, have this same type of setup, okay? When you get into larger firewalls that are a little more powerful, they have fewer ports, and you can put IP addressing right on the interface. You can do sub-interfaces. It acts more like a traditional router. So there's just a couple little idiosyncrasies about the 5505 that's different from other lines of firewalls. So int VLAN 2, which is outside. We give it an IP address of 204.184.21.30. With a 30-bit 7-net mask. Just like that. Okay? Same command. Alright. I do a show run now. you can see that Ethernet 00, which is connected to R1, has that switch port command like a switch. It's already attached to VLAN 2. These here that do not have that, it's inherently known that they are in VLAN 1. Okay, it's a given. So you have to change anything. You see that VLAN 1 has a name interface of outside. It has a security level. Now what security level means is this is kind of like setting up zones in a router, but a lot simpler. Okay, a security zone with a lower number is not trusted in reference to a security zone or a security level of a higher number. That means that traffic will pass from a higher numbered interface through a lower numbered interface regardless. You don't have to have an access list. Can you have an access list? Yeah, you can. But if you do not put an access list there, it will pass the packets, won't check them, nothing. All right. Conversely, from a higher number, from traffic coming from the, from a lower number going to a higher number, okay, you have to have an access list. Otherwise, it's going to block traffic by default. Okay, so higher to lower, it lets the traffic pass. Lower to higher, it blocks it. Okay. We also have to set up NAT and PAT so that any type of traffic that we send out, all right, will become established to allow traffic to come back in. Again, without an access list. All right, so we now need to put the IP address on VLAN 1. So I'm going to go into interface, VLAN 1. IP add, and its IP address is 10.0.0.1, 24-bit subnet mask. Okay, right there. Hit enter. It's already on. Show run. You'll now see that I have the IP set up on the inside and the outside interfaces. Now, what we're doing by naming the interfaces, that allows us to reference the interface in relation to traffic. Okay, so when we write an ACL, we do an access group, we apply it to the interface. We don't apply it to the interface by interface name. We do it by the name inf, or the name interface. It's a little confusing at first, but once you kind of get in the hang of it, it becomes second nature. Okay. Now we need to set up this DMZ. When you set up the DMZ, you're going to be creating yet another VLAN. You're going to get an error, but it's going to tell you what you need to do to fix that error. You have to do a license command. All right. So here I'm going to do the command interface VLAN 3. All right. Give it an IP address of 192.168.0.1 with 26-bit subnet mask. Okay. No shut. I need to give it a name and a security level. Because right now, if I do a show run, you'll see that that VLAN doesn't have that. It says no name interface, no security level. Okay? So I'm going to name the interface DMZ, all capital, and I'm going to give it a security level somewhere in between 0 and 100. Typically right in the middle of 0 and 100 at 50. So if I ever create another DMZ somewhere, I can figure out how I want to manage traffic. So I'm in that interface. I'm going to type in nameinf DMZ. Here's where you get the error. The license does not allow configuration of more than 2 interfaces with nameinf and without no forward command on the interface or on one interface with nameinf already configured. Okay? So here, the best way to do this is basically to put it onto the DMZ. We're just going to put the no forward command on it. So I'm going to type in no forward. Interface, VLAN, no forward interface VLAN 1. Okay? Alright, and now I can do the name interface command. Now it sets the security level to 0 by default, but I don't want it to be at 0. I want it to be at 50. So I'm going to type in security-level 50. Alright, now I've got my IP addresses together. Alright, number 2 is done. So, no routing protocols are going to be used here at all whatsoever. So you need to put in static routes for all devices and so you have 100% connectivity. Okay? Alright, so with that, we've got to take a look at the diagram and understand the flow of traffic. Okay? Now, you can put in default routes. That's perfectly fine. Alright? But there's a couple of static routes that you have to put in different devices so that traffic gets to where it needs to go to. Right? So, if I have a device that already has a network on it, it's what? Connected, right? So that device knows about that network, and if it gets a packet, it knows, oh, I can send a packet here. Alright? Same with the routers. Both of them, okay? But if there is a network on the other side of the device, it does not know about it. It does not know about it. Okay? So we have to set up routing in order to get to those networks. Alright? Now here's the catch-22. What do we have here? A 10 network and a 192.168 network. What type of networks are those? What type of IPs are those? I'll give you a hint. 50-50 chance. Are they public or are they private? Are they public or are they private? They're private, right? RFC 1918. Okay. Now, what do private addresses normally not do? They don't go where? They don't go to the public internet, right? Okay. So, do you think we need to tell the ISP router about those addresses? Probably not. Okay. Now, R1, do we need to tell R1 about those addresses? It depends. It depends. Okay. This is why I always tell you read through the entire lab instead of just going to number 1, number 2, number 3. But you may miss something. Okay. That's okay. For lab 3, what I suggest you do is if you want to go through step by step by step, that's fine. All right. When you're all done, go back to number 1 and go through it again. Okay. And if you're still not sure, go back to number 1 a third time and go through it all again as well. Okay. So if you don't, I can promise you, you're gonna miss something. You're gonna miss something. I'm looking in this lab for best practices. Best practices, like not routing private addresses out to the internet. Masking private networks, i.e. NAT and PAT. Okay? So, look in here. We need to get to the DMZ, which has a public IP space of 134.68.123.0/26. Right? R1 does not know about that network. Right now, the firewall doesn't know about that network, but we're going to take care of that in a different fashion with NAT. Okay? The inside network, where we have, and you can't see it on this, it's a little bit lower. We have a directory server, DNS server, right? An active directory server. We may need to route traffic there. That's why I say go do it a couple times. All right. So default routes basically are going to be used to flow traffic out to the world, out to the internet. All right. So that's the easy part. Let's get that done first. So if I need to put a default route in the router to get to the internet, all right, it's going to be IP route 0.0.0.0, 0.0.0.0, gateway. Gateway being .33. You did that in lab 1, you did that in lab 2. Really easy. Let's knock it out. Oh, that's the firewall. My bad. All right, IP route. And then my gateway is 204.184.21.33, which is the IP address of the ISP router. Might be helpful if I go into global configuration mode. Okay. Now R1 also needs to know about this network and how to get to it. We don't have it configured yet, we will. So I need to do a static route to the firewall telling R1 where that network is. I want to do the IP route command again, this time with the specific network, 134.68.123.0, 255.255.254. And the next hop is 204.184.21.30, which is the firewall. Okay. That's all you really need to do on R1. Okay. Now the ISP router, it needs to know about these networks as well. So we're going to set it up in similar fashion. Now you don't have to do a default route on the ISP router. That's a given. Okay, don't worry about it. So I need to tell it about this network and this network. I don't want to tell the ISP router about my private network. IP route 204.184.21.28, 255.255.255.252, and its next hop is going to be .34. Okay? That tells it where to get to that /30 network. And the same thing with the 134 network. IP route 134.68.123.0. Same next hop, 204.184.21.34. Okay? Don't worry about a default route there. Don't worry about a default route to the internet. Because I didn't give you an IP. That's fine. So R1, if we want to do a show run, should have a couple static routes, default route and one static route. And on the ISP, we should have 2 static routes. There you go. Okay? Now on the firewall, you do not have an IP route command. Firewall is more along the lines of a Linux style command for our static router. Alright, so pay attention. And all we have to do for the firewall, okay, since this network is in the same direction as everything else, we don't have to put in a static route for this network. We put in a default route, it's going to fall there anyway, right? So we just have to put it in a default route. The syntax is a little different. So we need to be in global configuration mode, so I'm going to exit out of the interface. And the route command, or the IP route command, is just route. Route. The network and mask, which default is again going to be all zeros. 0.0.0.0, 0.0.0.0. The next hop, which will be the inside interface of R1, 204.184.21.29. And then you have to tell it, well, what interface am I sending this out of? Okay, that is the name interface, or name if, that you did on that VLAN, which is outside. It is case sensitive. It is case sensitive. So the interface was all lowercase. All right. Enter. Oops, I put it in the wrong spot. It's route outside, and then my fault. Getting my Linux and my ASA commands confused. Route outside, you have to tell what interface it's exiting, the network mask, and then the next hop. I'll leave that there for a second. Route outside 0.0.0.0. 0.0.0.0. Next hop 204.184.21.29. Okay? And that's pretty much all the routing you need to do. For now. Alright, we'll get to that later. On R1, configure and apply an access control list that will prevent RC19 networks from being sent out to the internet. You have done this before, right? Other labs? Okay, you can do that on your own. Number 5. NAT your DMZ servers to the public IP provided in the diagram. Now, here's a trick. Alright, here's a trick. You can do this on a one-for-one basis, which I suggest. Alright, or you can do it all network at one time. Alright, let me show you again the best practice. We're doing it one at a time. And you need to reference your little table here. Okay. So using the NAT command, I'm going to do the mail server. 192.168.0.21. Oh, that's messed up. My diagram's been, how my diagram is messed up? Whoops. This should be a 21, not a 22. Don't worry. If you mess it up, I won't count off on it. Alright. I'll do the web server. The web server being 192.168.0.13, mapping to 134.68.123.13. Okay? So, from global configuration mode, you're going to use the NAT command. The NAT command. And you're going to look at how traffic is going to get there. So we're going to NAT from the outside to the inside. The outside to the inside. All right? Which is going to be backwards, and then backwards again. It's really confusing. I'm sorry. All right? Just the way that this manufacturer does NATing. So NAT, open paren, inside, comma, outside, no spaces, close paren. Then the global address, which is the 134 address. 134.68.123.13. Oops, hold on. You know what? I don't want to confuse myself here. Okay. There are two ways that you can do NAT in Cisco ASAs. All right. And there's the old way, which is pre 8.3, and then the new way, which is 8.3 and higher. All right. What you're going to do in this case is you're going to create some network objects. All right. You're going to name the different servers. All right. And then you will do the NATing under that specific network object. Okay? So, sorry for confusing you, but I caught myself before I made a mistake. So, we're going to go ahead and create an object. Object. Network. And then the name. So you can use the names here in the table: web, mail, FTP, DNS. Again, whatever you do, it's going to be case sensitive. Web. All right. We go into object configuration mode. Then you give it its IP address. Its local IP address. Its local IP address. So you do that with the host command. I'll do a couple of these so you catch on. Host, and then the IP address 192.168.0.13. Enter. Okay. Then you can do the NAT command. From this prompt. NAT, open paren, all right, inside, comma, outside, static, which means it's going to be a one-for-one mapping, and then the IP address of what it's going to be NATed to, which is the public IP. 134.68.123.13. That's it. Okay. I'll roll through that again with the mail server, which is .21. Okay. Global configuration mode. You're going to create a network object. Object. Network. Okay, and then the name. So in this case, it will be mail. Everybody with me? Object, network, the name. Okay? Then when your prompt changes, you're going to type in host, and then it's local IP address, the 192.168 address. Then you're going to do the NAT statement. NAT, open paren. Oh, I goofed. I totally goofed. What did I name this interface? It's not inside, is it? What did I name it? Again, I caught myself. You guys are supposed to catch me. I goof up like this. What did I name that interface? I made it VLAN 3, right? All right. Ever confused? From anywhere. Doesn't matter. Do a show run. Oh, I named it DMZ. So, no problem. NAT, DMZ, comma, outside, again, case sensitive. No spaces. Static, and then the public IP. 134.68.123.21. Alright? So, if you make a mistake, don't worry about it. Get to where your mistake is and just take it out. And I'm doing this by design. I meant to goof up. At least that's what I'm going to tell you. I'm sticking to the story. Alright? So you see where I messed up with the web, right? You see where the mail server is correct. The web server is not on the inside interface. It's on the DMZ interface. Right? So I have to go into that object. Object. Network. Web. I just take that NAT statement out. Now, if I caught it soon enough, I can hit the up arrow enough times to where I put that command in. Hopefully. There it is. Just go all the way to the left. Type in no space. And it'll take it out. Everybody with me? Okay. Check it. Sure. Show run. Right? You see that I have the... Oh boy, did I lose my object altogether? That's weird. Huh. I sure did, huh? Only have my mail object in there. Okay. Object, network, web, host, 192.168.0.13, NAT, DMZ, outside, static, public IP, 134.68.23.13. And that got me back to where I was. Okay? Cool. All right. Next, I found another mistake I made. All right. I do not have my Ethernet 01, which is connected to my DMZ switch, on the right VLAN. The outside interface is fine. The inside interface is fine by default. So I got to go do a switch port access VLAN 3 on Ethernet 01. Int F03. Int, oh, Ethernet 03. E0/3. Switch port, access, VLAN 3. All right. Did I do that right? Ooh, I don't think I did. I think I goofed up again.